Welcome to qnawire.
Okay, let's look at the questions. So, sound from speakers, sound of frequency 680 Hz is synchronized as it leaves two speakers that are separated by 0.80 meter on an open field. So first we need to draw a sketch of this arrangement and draw a line from between the speakers to a location where the sound is intense and equal distance from the two speakers, the zeroth order maximum. So that's a graph we'll get. So the distance between two speakers is 0.80 meter. So two speakers are here. You see the green dot? Yeah, those are two speakers. And there's a straight line cross between two speakers. And this straight line is the zero order maximum. Okay. So for the second question, let's take a look. It says determine the angular deflection of a line from between the speakers to the first order intensity maximum to the side of this zeroth order maximum. And the speed of sound is given, which is 340 meters per second. So let's see. We know speed of sound is equal to 340 meters per second. The distance between two speakers at 0.80 meter, and the frequency is 680 hertz. So we need to find the angular deflection. So the theta here is unknown, but we know there's an equation for the theta, which is sine theta m equals m lambda divided by d. M here is the orders, lambda here is the wavelengths, and d here is the separation between two sources. And in this question, is the distance between two speakers. So m and d is known from this question because m is just simply equal to 1 because we are looking for the angular deflection of the first order intensity maximum to the side of this zeroth order maximum. So the m is just equal to 1. So m and d is known. So how can we find lambda? Well, first we know v, v, the speed of the sound, is equal to lambda times f. Lambda is wavelength and f is frequency. So therefore, lambda can be equal to v divided by f, which is speed of sound divided by frequency. And then we get 340 meter per second divided by 680 hertz. And then we'll eventually get 0.5 meter as the wavelength. So 0.5 meter is the wavelength. So we know the wavelength, so we can plug in all the data into the equation sine theta m. Then we get sine theta m is, actually in this case, let's change the m to 1 since we know the m. It's 1 and equal to 1 times, this is the dot product, so it means multiply, times lambda. Lambda is 0.5 meter. Okay, and d is 0.80 meter. Then we get 0.625. In order to get theta 1, we need to use arcsine, or the inverse of sine function, to get theta, and that's equal to sine to the power of -1, which is inverse sine or arcsine, 0.625, and eventually the answer should be 39 degrees. So that's the angular deflection for this question. Thank you.